In the last video, we learnt about what alkanes are, basically. And then I said that I'd mentioned something about isomerism. And we've just been having a play with molecular models to make as many isomers of C5H12 as we can. When we get given a question like this, the first thing really that we should be doing, so step one as it were, is look at the general formula. And it's CnH2n plus 2. So we know that it can only be an alkane and it can only be straight chain. So we're not going to waste our time making cyclics because that doesn't match that general formula. The second thing we're going to do is make the most obvious one, what we call the straight chain version of it, where it's just 5 carbons in a row, then plug in the hydrogens, and we get this condensed structural formula. Then we have to be able to name it, and that's our next challenge. Now for this one it's quite easy because it's what we call a straight chain. But you'll see these ones here, they've got carbons coming off in funny angles as well. These are what we call branched. So this is called a straight chain. And these are the most common alkanes found in crude oil. But you also find some of these. And these are your branched alkanes or hydrocarbons. So how do we name them? Well, the first thing we do is look for what is the functional group. Well, there is no functional group here. It's a hydrocarbon with no double bonds or anything. So we know that the name must end in the suffix ane. So you'll see that I actually write these backwards. I start at the suffix and then I do the prefixes. Then I find my largest carbon chain. My largest carbon chain has got 1, 2, 3, 4, 5 carbons in it. Now, just to show you how it is, I always number it both ways. And you'll see why in a moment. So 1, 2, 3, 4, 5. Now in a test, I recommend you do that in pencil because it's just working and you don't want the examiner to mark it. Alright? 5, meth, eth, prop, bute, pent. So it's pentane. So I write that. And there we go, there's its name. I then check, is there any side chain coming off it? And no, there isn't. So that means I've got the answer there. Alright? This next one, though, is branched. It's got this CH3 coming off here. Instead of this being CH2, CH2, CH3, it's almost like this has been broken off and put in here. And this one here, again, we look. What's the functional group? There isn't one, so it's an alkane. So I write down ANE. Then I find the biggest carbon chain. Well, that could be there, or it could be there, or it could be there, or it could be there. It can go either way. It's easier to take it as the straight bit, but actually both of these are equally correct because they both contain 4 carbons. I'm going to go through the middle because I find it easier. And you'll see I number it both ways. Alright, so it's going to be a butane. Meth, eth, prop, bute. 4 carbons, it's a butane. My next thing is, are there any side chains, any carbon chains or things coming off that? Well, yes, there are. There's this one here. And the side chain is made up of 1 carbon. If the side chain is made up of 1 carbon, meth means 1, so it's called methyl butane. So this is wherever you see this in some of the antibiotics and things that you have to use. If it says methyl, it means it's got a CH3 group coming off the side of its biggest carbon chains. So it's got a 1 methyl group coming off it. Now, if there was other methyl groups coming off this, then we'd have to say what number carbon it's on. So, in this case, if I move the methyl group to there, it's still on the same carbon. It's on a carbon with 2 on it. But actually, technically, this should be called 2-methyl butane because the methyl group is on carbon number 2. Now, it's on number 2, not number 3, because we always choose the lowest number that we can. Alright, so you'll see that when we do isomers and things like alcohols and so on, where they get a bit harder to do.
So why don't you need to?
We don't need to, because if I move it there, it's still on carbon number 2. That's why I number both ways, so that if I move it, it's still number 2, so nothing's changed. Alright, good question, very good question. And that explains why I number it both ways.
If you had 2 chains coming off, would it be
No, it'd have to be CH2, CH3 coming off. If you have, we're about to get that actually, where it's got a methyl group there and there. So we're about to do that, so I'll answer that question by doing this one. Again, it's an alkane. Its largest carbon chain, let's go through the middle, is 1, 2, 3. Alright, so it is propane. And this might answer that question we were just asked. It's got side chains, and it's got 2 of them. So, for this, you say it's dimethyl propane. Di for 2, methyl because that's how many carbons on each of them, dimethyl propane. Or dimethyl if you prefer to say it that way. Alright, so these are our isomers of C5H12. Again, I don't have to put the number there because I can't put those methyl groups anywhere else. They have to be on carbon 2. If I put one of them there, I've just turned it back into methyl butane.
What do you call the last one? You got like straight chain, branch?
Oh, both of these are branched.
Okay.
Yeah, good question. Anything where it's got a methyl or an ethyl, remember ethyl's 2 carbons, where it's got a side chain coming off, we call that branched. Okay, so we call these things side chains, the ones that I've circled. Alright, so those isomers, structural isomers, we find in our alkanes. There's no other type of isomerism that you need to worry about in straight chained and branched. In cyclics, there's other things happening, but you don't learn about those until level 3.
What if you had another branch going off on the branch?
So if I had, then that would just make it a longer chain. If I put another one there, for example, then actually the largest carbon chain would be 5 carbons because it would go down that way. Yeah, and there, for that one, that's a good example you give. I might put that over here if the space, see if the screen's going to get me. Yeah, the one that has just been mentioned I will put up. If I had CH3, CH2, CH, CH3, and then put CH2, CH3 down there. Is that what you meant? Something like that? Cool. Okay, in this case, this is commonly done in NCEA. It's a trick question because the largest carbon chain is here. 1, 2, 3, 4, 5 carbons. So it's a trick question. So I number that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And the reason I do that is I could actually, so this is my side chain here. You'll find it's usually methyl. It's very rare for it to be anything other than methyl because we're only looking up to 8 carbons this year. So for this one here, you have to name that as methyl, actually 3-methyl and 5 is pent, so 3-methyl pentane. Now the reason I need the number on this one, is if I could actually put that methyl group on the number 2 carbon, so this one or this one, and it would actually change it. So it wouldn't change a lot of its properties, to be honest, but it would be a different compound. Alright, so I do need to say the number for this one. But I don't need to say the numbers for these because I can't put it anywhere else. It makes the same molecule. Alright. So if it's an alkane, you're only looking at structural isomers. The trick with that is working out what its branched chain versions are and being able to name those. Side chains, if they've got 1 carbon, are called methyl. If they've got 2 carbons in them, are called ethyl. If there's more than one side chain, so more than one methyl group, you say that it's dimethyl. If there are 3 of them, trimethyl. Alright.
So this also getting into like isomerism?
Definitely, yes. Alright, so you're starting to name, or you're having to come up with these in your head without the models in front of you. So yes, you are looking at your merit type work here. Alright.